Male narrator, VO. The unsung architect of the invisible universe, Vera Rubin's Odyssey. In the vast tapestry of modern astronomy, few figures shine as brightly yet as overlooked as Vera Cooper Rubin, the trailblazing American astronomer whose meticulous observations in the 1970s unveiled the invisible scaffolding holding galaxies together, dark matter, the enigmatic substance comprising about 85% of the universe's mass. Male narrator, VO. Born on July 23, 1928 in Philadelphia, Pennsylvania to Philip and Rose Cooper, Vera grew up in a family that nurtured her insatiable curiosity. Male narrator, VO. Her father, an electrical engineer, encouraged her early fascination with the stars, often taking her to observe the night sky from their home's rooftop in Washington, D.C., after a move in 1938. Male narrator, VO. By age 14, she had built her own telescope from scrap parts, a testament to her ingenuity in an era when women were rarely encouraged to pursue STEM fields. Male narrator, VO. Rubin entered Vassar College in 1946, one of only 3 women in her astronomy class, graduating in 1950 with a degree in astronomy despite facing skepticism from male professors who questioned her choice of a man's field. Male narrator, VO. Her undergraduate thesis on galaxy motions hinted at her future path, revealing an early interest in cosmic dynamics that would define her legacy. Male narrator, VO. Undeterred by societal barriers, Rubin married Robert Rubin, a chemist, in 1948, and balanced motherhood, raising 4 children, while pursuing graduate studies at Cornell University. Male narrator, VO, where she earned her master's in 1951 under William Shaw, focusing on the expansion of the universe. Male narrator, VO. This period marked the beginning of her lifelong battle against gender biases in science, as she was often denied access to observatories and faced dismissive attitudes. Yet her passion propelled her forward, laying the groundwork for discoveries that would reshape cosmology. Vera Rubin's doctoral journey at Georgetown University, completed in 1954 under theoretical physicist George Gamow, a pioneer in Big Bang nucleosynthesis, thrust her into the heart of extragalactic astronomy, with a thesis titled Contribution to the Problem of the Extragalactic Distances, which explored whether galaxies recede at speeds proportional to their distance, affirming Hubble's law through innovative photographic techniques. Gamow, impressed by her analytical rigor, became a mentor, but post-PhD Rubin encountered stark professional hurdles. As a woman with young children, she was relegated to teaching at Montgomery County Junior College and later Georgetown, where she instructed future astronomers while conducting research at the Naval Research Laboratory, using modest equipment. In 1960, she presented her first major paper at the American Astronomical Society, observing that spiral galaxies like Andromeda exhibited unexpected motions, hinting at large-scale structures in the universe, a finding that challenged the prevailing view of a uniformly expanding cosmos and foreshadowed her later work on galactic clustering. This presentation, delivered to an all-male audience, drew polite interest but little collaboration, underscoring the isolation women faced. Yet Rubin persisted, collaborating with her husband on early projects and using summer access to the U.S. Naval Observatory to refine her skills. By the mid-1960s, her persistence paid off when she joined the Carnegie Institution's Department of Terrestrial Magnetism in Washington, D.C., where she gained access to the groundbreaking image tube spectrograph developed by Kent Ford, a tool that would become her scientific Excalibur, enabling precise measurements of stellar velocities invisible to traditional spectrographs. The pivotal collaboration with Kent Ford in the late 1960s revolutionized Vera Rubin's research, as their custom-built spectrograph, a sophisticated device amplifying faint light signals by factors of 10 to 20, allowed her to capture detailed spectra from distant stars, transforming galaxy rotation studies from guesswork to precision science. Ford, a quiet instrument maker at Carnegie, complemented Rubin's observational prowess with technical innovation, and together they targeted spiral galaxies like Andromeda, M31, expecting to confirm Keplerian decline. Stars orbiting slower at greater distances from the galactic center due to diminishing gravitational pull from visible mass. Instead, in 1965, observations at the Kitt Peak National Observatory's 84-inch telescope, Rubin and Ford uncovered a shocking anomaly. Outer stars maintained flat rotation velocities, hurtling at 200 to 250 kilometers per s regardless of radius, implying unseen mass extended far beyond the luminous disk. This rotation curve flatness defied Newtonian gravity, suggesting an invisible halo enveloping each galaxy, a concept Rubin pursued relentlessly over the next decade. Publishing their first joint paper in 1970 in the Astrophysical Journal, they analyzed 10 galaxies, with Andromeda's curve providing the clearest evidence. But skepticism lingered. Astronomers like Margaret Burbidge urged more data, which Rubin duly provided, amassing spectra from over 200 galaxies by the 1980s. Her methodical approach, nights spent at telescopes in Arizona and Chile poring over photographic plates, yielded irrefutable patterns, confirming Fritz Zwicky's 1930s hypothesis of missing mass in clusters, but extending it to individual galaxies, where dark matter dominated the mass budget by a factor of 10. 1. Vera Rubin's groundbreaking 1970s observations at the Palomar Observatory's 200-inch Hale telescope solidified her evidence for dark matter, as she and Ford measured rotation curves in 21 spiral galaxies, revealing universal flatness that could only be explained by a spherical halo of non-luminous matter exerting gravitational influence without emitting or absorbing light. In her seminal 1980 paper, Rotational Properties of 21 SC Galaxies, Rubin quantified this. Visible matter accounted for mere 10 to 20% of galactic mass, with dark matter comprising the rest, distributed in extended halos reaching 50 kiloparsecs, 5 times the luminous radius. This wasn't mere anomaly, it was systemic, observed in SB-type spirals like M81 and M101, where orbital speeds plateaued at 150 to 300 kilometers per s, defying Kepler's inverse square law. Rubin presented these at the 1975 American Astronomical Society meeting, igniting debate. Some invoked modified gravity like MOND, but her data's consistency, corroborated by radio astronomers' 21 cm hydrogen line mappings, tipped the scales toward dark matter. By 1982, her work with collaborators like Burstein and Thonard expanded to 60 galaxies, showing dark matter's ubiquity, from dwarfs to giants, revolutionizing galaxy formation models, halos as cosmic scaffolds, seeding structure via cold dark matter simulations by Peebles and others. Rubin's persistence, overcoming equipment failures and weather woes, yielded datasets that remain foundational, her spectrograph's light-gathering power enabling spectra from stars as faint as magnitude 22, a feat unmatched until digital CCDs. The profound implications of Vera Rubin's dark matter evidence rippled through cosmology, providing the empirical backbone for the Lambda CDM model, where cold dark matter drives hierarchical structure formation from tiny fluctuations in the cosmic microwave background. Her rotation curves explained why galaxies don't fly apart, revealing dark matter's gravitational glue binding 85% of the universe's mass, invisible yet omnipresent, influencing everything from large-scale flows to bullet cluster collisions observed in 2007. Rubin herself, in her 1997 book Bright Galaxies, Dark Matters, reflected on this as a quiet revolution, noting how her findings shifted paradigms from luminous-dominated to dark-dominated universes, aligning with Zwicky's cluster evidence and Oort's local discrepancies but providing the first direct galactic proof. Yet she remained open-minded, exploring alternatives like counter-rotating gas in mergers. Her 1992 discovery in NGC 4550, where half the stars spun opposite the disk, evidenced violent galactic births. By the 1990s, her data fueled supercomputer simulations at Princeton, showing dark halos as cuspy profiles with central densities, though recent 2025 JWST observations of early galaxies challenge cusp core debates, keeping her legacy dynamic. Rubin's work not only quantified dark matter's dominance, ratio of dark to visible matter at 10:1 in spirals, but ignited hunts for its nature from WIMPs to axions, with experiments like Lux Zeppelin in 2025 owing her a debt of observational rigor. Beyond her scientific triumphs, Vera Rubin's advocacy for women in astronomy was as luminous as her discoveries, mentoring dozens of female students at Carnegie, and co-founding the Committee on the Status of Women in Astronomy in 1972, which documented pervasive discrimination like observatory bans for women. Facing her own battles, denied Carnegie membership until 1981 despite her seniority, and relegated to guest investigator status, she channeled frustration into empowerment, quipping in a 1992 interview, "There is no problem in science that can be solved by a man that cannot be solved by a woman." Her Berkeley 1996 commencement address inspired generations. You can do it too. You are made of star stuff, and you are connected to the universe. Rubin balanced career and family masterfully, crediting her husband's support, and by the 2000s, her protégés like Netta Baykal led NAS sections. In 2025, as the Vera Rubin Observatory in Chile begins operations, its 8.4-meter LSST telescope mapping dark matter via weak lensing, her advocacy echoes in diversity initiatives, with 40% female teams, a far cry from her era's 5%. Her quiet feminism, refusing to let barriers dim her light, paved paths for trailblazers like Jocelyn Bell Burnell, proving perseverance trumps prejudice. Vera Rubin's accolades, though not including the Nobel, a glaring omission debated in 2025 physics circles, with Lisa Randall calling it an oversight tied to gender biases, nonetheless illuminate her impact. The 1993 National Medal of Science, NAS election in 1981, and Discover's 2002 50 Most Important Women in Science nod. The 2019 renaming of the LSST to Vera Rubin Observatory atop Cerro Pachon honors her dark matter legacy. Its 3.2 gigapixel camera set to image the southern sky every few nights, probing 20 billion galaxies for dark energy's waltz with matter. Carnegie established a postdoctoral fund in her name, and the AAS's Dynamical Astronomy Division awards the Vera Rubin Early Career Prize annually. Posthumously, after her December 25, 2016 passing from dementia complications at 88, biographies like the Mittens 2021 Vera Rubin, A Life in Nichols children's book, The Stuff Between the Stars, 2019, celebrate her, while 2025's Observatory First Light, capturing millions of asteroids and dark matter maps, fulfills her vision of an accessible cosmos. Rubin's humility shone in refusing solo credit, always crediting Ford and Zwicky, embodying science's collaborative spirit. Vera Rubin's personal life wove seamlessly with her professional odyssey, a tapestry of 4 children, David, Judith, Carl, and Alan, all pursuing science or medicine, reflecting her nurturing ethos amid late-night observatory vigils. Married to Robert for 60 years until his 2008 death, she credited family as her anchor, often bringing children to telescopes, fostering a legacy of wonder. Son Carl became a geophysicist, daughter Judith a systems biologist. Rubin savored simple joys, gardening, chamber music, and Jewish traditions, yet her intellect never dimmed, authoring over 150 papers in the accessible Bright Galaxies, Dark Matters, 1997, blending memoir with cosmology. In interviews she mused on dark matter's poetry. Most of the universe is dark, like most of us. Her faith in science's democratizing power, science belongs to all of us, drove outreach, from PBS's 1991 The Astronomers to school visits, inspiring underrepresented youth. By 2025, as Rubin Observatory data floods in, her holistic life, scientist mother advocate, reminds us genius thrives in balance, her star stuff seeding countless dreams. The controversies surrounding Vera Rubin's Nobel snub persist into 2025, with physicists like Emily Levesque arguing it overlooked her paradigm shift, akin to Zwicky's unawarded cluster work, while others cite timing, her evidence built gradually, peaking post-1980 s. Forbes' 2017 piece Who Really Discovered Dark Matter? Equivocated, crediting Zwicky's prescience but Rubin's proof, fueling debates on recognition's gender gap. Rubin herself demurred, focusing on science over prizes, but her absence stings, especially as 2011's Dark Energy Nobel echoed her era's oversights. Yet her true monument is the Rubin Observatory's 2025 legacy. Surveying 10 billion galaxies, it hunts dark matter's fingerprints in lensing and streams, validating her halos while probing alternatives like modified gravity. As data reveals 80% dark matter's sway, Rubin's quiet revolution endures, a beacon for equity and inquiry. Vera Rubin's enduring impact transcends dark matter, igniting fields from particle physics WIMP hunts to cosmology's multiverse musings, her rotation curves anchoring simulations that predict cosmic web filaments seen in 2025's Euclid maps. By quantifying dark halo's universality, from Milky Way's 1.5 million kilometers per s terminal velocity to Virgo cluster's Zwicky mass, she bridged observation and theory, influencing Peebles' 2019 Nobel for Structure Formation. Her counter-rotation discoveries in mergers like NGC 4550 illuminated galaxy evolution's violence, seeding today's hierarchical models. In 2025, as Rubin Observatory's time domain surveys catch transients revealing dark matter's clumpiness, her ethos, rigor, humility, inclusion, guides diverse teams, with women comprising 35% of LSST leads. Rubin's life, From rooftop stargazing to cosmic veils unveiled, embodies science's poetry. In darkness lies revelation, urging us to peer deeper, kinder, bolder. As Vera Rubin's story unfolds in 2025's Observatory Glow, her legacy whispers, "The universe's secrets hide in persistence, not privilege." From a girl's homemade lens to dark matter's throne, she proved one woman's gaze can illuminate the unseen, challenging us to seek our own pale blue dots amid the stars. If her tale stirs your cosmos, share it. Science belongs to all, and so does wonder.